Hi, and welcome to this Systems of Equations session, part 3 on graphing, another power session with Mama L. What you'll learn in this session today is how to solve a system of equations using graphing. The 3 ways to solve systems of equations are substitution, elimination, and graphing. This is my third and final session over the topic. So you might see a question like this: given the system below, solve for x and y to find the point of intersection. All right, what you might not realize is that when you have equations with x and y, they're having you basically draw a picture of all your answers. When you have an x, that goes on your number line horizontally. When you have y, there's a number line that's vertical, and when you connect your x and your y, you get points. And so every time you put a point, you end up making a line. Now sometimes with different kinds of equations you can get parabolas or hyperbolas in different shapes, but we're just talking about simple linear equations here, and we have x's and y's and we're drawing pictures. So where our lines intersect, that's going to be the solution to our system of equations. So it's a picture of our answer, which is kind of handy. Now sometimes you can get just one point where they cross. Other times you can have parallel lines and they're not going to have any points in common. And you could also have lines that overlap and they're going to have infinite or all points in common. So let's take a look at these two equations right here. Okay. Your first step is to put them in slope-intercept form. So here's slope-intercept form, where you want to have y all alone, and then your x is next after the equal sign, and then all your plain numbers stuck in the back, basically. Okay. So if you want y all alone, you have to get the 8x to the other side. I'm going to take that 8x away. Now that negative comes with my 2y, so I still have negative 2y. I'm putting my x's next. Negative 8 of them, and then I have a positive 10. So it looks like negative 8 plus 10. Then just divide by negative 2 for every term or chunk of that problem, and you get positive y, that's what we wanted, and then negative 8 divided by negative 2 is positive 4, and then 10 divided by negative 2 is 5. So right here is our new version in slope-intercept form. Same equation, same line, same picture and everything, just looks a little bit different. This next one's a little bit easier. Negative 3x, take that from both sides, that 3x from both sides. We get our y positive and alone, just like we want. Negative 3x is on the right, positive 2. Remember, you want your x's first and then your plain numbers. So that's our new version right there. Now remember, when you're graphing a line, the slope-intercept form has the y-intercept in the back. Okay, that's your starting point of where you start drawing your line. From there, you use the slope. If it's not in fraction form, you can put it in fraction form. So my starting point is negative 5, and from there, on my y-axis, I'm going to go up 1 over 1, up 4 over 1. Okay, your slope tells you how far to rise and how far to run. Same thing is true for this next one. My starting point will be positive 2, and then I'll go from there down 3 over 1. So let's take a look. I'm going to go ahead and do this first one. Starting point on my y-axis, it's my y-intercept, negative 5. From there I'll go up 4 over 1, up 4 over 1, and so on. And then connect your dots, and that line is a picture of all the points that could be plugged in for x and y to make that equation true. Not the prettiest line. All right, let's try another one in a different color. Now my starting point is positive 2. Okay, there's my starting point, my y-axis. From there I'm going down 3 over 1, down 3 over 1, down 3 over 1, and so on. There's that line. The point where they both overlap is right here. It was over 1, down 1. That's the point. Just like x and y give us our coordinate points when we're drawing points on a line or a graph, those are our solutions. X equals 1 and y equals negative 1. Literally, if I plugged in 1 and negative 1 for x and y, both equations would become true. All right, so your graphing steps. First, write down both equations in slope-intercept form with your y all alone, then your equal sign, your number of x's, and then your plain numbers. If your plain numbers are negative, this is going to be a minus sign. Remember, your y should not be negative. It needs to be positive. Second, graph each equation on the coordinate plane, and 3, where the lines overlap, if they do, because remember sometimes we can get parallel that don't overlap at all, That's the solution to your system of equations. So let's take a look at two examples. So this first example, I have A's and B's. Okay, if the A's and B's throw you off and worry you, don't worry about that. You can change them to X's and Y's so you feel more comfortable putting it into slope-intercept form. Okay, but just make sure that if you change the X or the A to X, that you do that appropriately in both of the equations. Don't accidentally flip it on the other side. Okay, so our second step is to go ahead and move on, and now we need to go ahead and do slope-intercept form. So let's add 3x to both sides. When I add 3x to both sides, I get my positive 3y all alone on the left. I get my 3x's on the right, and my plane 9. It was positive as well. I'm going to divide each chunk or term of my problem by 3, getting y all alone. X just is 1x, and then 9 divided by 3 is 3. Let's change colors for the different equation. Alright, for this next equation, we're going to add 5x to both sides because we want to get our y all alone. Negative, that negative comes with my y, right? I've got positive 5x and I've got positive 24. Let's divide by negative 4 for every term or chunk of our problem. Now we have a positive y, we have a negative 5/4, and we have a minus 6 because positive 24 divided by negative 4 is negative 6. So those are the equations that we need to graph. Y equals x plus 3, because 1x plus 3 is the same. If you want to put 1 over 1, that's your slope. And then we had negative 5/4 x minus 6. Alright, so let's start with the first one. Let's put that one in blue. Start at my point of positive 3 on my y-axis, and then from there up 1 over 1, up 1 over 1, and so on. Doesn't take long to see what my line looks like. And then my next line, I'll put in green. My starting point here is negative 6 on my y-intercept, for my y-intercept, and I go down 5 over 4. So 1, 2, 3, 4, 5 over 4. Okay, I could also go up 5 to the left 4. So down 5 over 4 or up 5 to the left 4 are the same thing. So I'll do that. Up 5 to the left 4. And it looks like right here is where our lines would intersect. Not super pretty. Alright, but right here. So at negative 4, negative 1. So our x would be negative 4, our y would be negative 1. Let's try one more example. Let's take away our x's. We've got negative 5y, then we've got negative 2x's and negative 23. Lots of negatives there, right? Divide by a negative 5 for every term or chunk of our problem. And y is positive and alone. That's what we like to see. X is positive 2/5 because those negative signs cancel out. And then negative 23 divided by 5, well, that goes in 4 times with 3 left over. Okay, a negative divided by negative is a positive. So we have 4 and 3/5. Now that might look strange, but that's okay and that's normal. Sometimes you're going to go between the grid lines on your coordinate plane. Okay, let's go ahead and solve the next one. Take away 6x from both sides. 6y equals negative 6x minus 6. Let's divide by positive 6. Y is positive and alone. We get negative 1 or negative 1 over 1x minus 1. So let's take those two equations and put them on the next screen. So if we go ahead and want to graph these equations, we have to have our starting point. So positive 4 and 3/5 is going to be about right here. From there I go and follow my slope. So I go up 2 over 5. So up 2 over 5. I could even go down 2 over 5. Okay, and I could connect those and make my line. I could go ahead and do my next graph. My starting point is -1. And from there I go down 1 over 1. So this is a negative slope. So from the left to the right, my line is going to slope down. Down 1 over 1, down 1 over 1, and so on. I could go up and to the left as well. And it looks like my line is going to have a solution somewhere around -4, +3. So my x is -4, my y is +3. If I were to plug those into my equations, I would see that the left side of my equation would equal my right side when I simplified using order of operations. And that's it. Thanks for watching this final session on systems of equations. Hopefully you learned something and you can enjoy some of my other power sessions. Take care.